Hello everyone, welcome to reInvent. I'm Prateek Sharma, Senior Solutions Architect with Strategic Accounts team at AWS. I work closely with Netflix security team, and today I'm thrilled to introduce Curtis Castropel to you. Curtis is a senior software engineer at Netflix. In many organizations, security team is the sole arbiter of IAM permissions across hundreds of accounts. This can sometimes lead to heavy support burden on the security team. Curtis went through a similar journey and has come up with a creative solution with ConsoleMe to simplify management of multi-account IAM permission requests and improve the end-user experience. Over to Curtis for a deep dive on this topic. Thank you.
One of my favorite hobbies is surfing. On one particularly foggy Saturday afternoon surfing in the Bay Area, a powerful wave came and ripped my board out from under me, including the leash that keeps the surfboard attached to my leg. It pushed my board to the shore, and there I am, stranded amongst the waves, struggling to paddle towards land. With every stroke I take, it feels like I get pulled back 2 more. Wave after wave comes and pummels me under the water, and I'm not making any progress towards my goal, despite all the effort I'm exerting. I'm just getting more and more exhausted, and every new wave seems more difficult to surpass. I feel like it's an endless struggle. When I compare these waves to the ups and downs of managing a growing cloud environment, I imagine a lot of you here have similar struggles. We want to innovate in our respective fields, but progress is hindered by events that aren't always under our control. Things don't always go as planned, and our leash sometimes breaks. Today, I'm going to talk about some of the waves that we've encountered as we've scaled out with multi-account AWS IAM at Netflix, how we overcame these challenges, and how you can too. Because when you do catch a wave, the excitement is exhilarating. My name is Curtis. I work as a security software engineer on the cloud infrastructure security team at Netflix. My team owns the entire IAM workflow across hundreds of accounts. I like to compare our growth in the cloud to a city that has grown faster than the planning can keep up with, like Tokyo pictured here. We've been constantly adding more roles, resources, configurations, accounts, and you name it, into our cloud environment. This caused a problem for us. Since we're the only team that can add or remove IAM permissions at Netflix, we've historically had a large support burden that has increased on par with the company's growth. We found that our pain was only bound to grow from here. This is a graph of the number of Slack support messages our team received from the end of 2017 to early 2019. Notice the upward trend? The company was growing exponentially, but our team wasn't growing at the same rate. We needed to automate and scale, and we needed to do it fast before our innovation was paralyzed by our support demands. I bet this sounds familiar to some of you. So we went to the drawing board and imagined what it would take to organize the chaos. We wanted to improve the experience for our customers and ourselves, provide more consistency in how we grant permissions, and enforce least privilege by provisioning applications with fewer permissions while giving users a streamlined way to get what they need. We also wanted to make multi-account AWS IAM less complex by centralizing the parts users interact with the most in a single interface. We developed a service called ConsoleMe. Initially, ConsoleMe's purpose was just to centralize how non-machines like Netflix employees and contractors got access to the AWS console and how they retrieved IAM credentials locally for their services. But the scope expanded from there. Now, ConsoleMe consolidates the management of multiple accounts into a single web interface. It provides native interfaces for end users and your cloud administrators to request and manage permissions for IAM roles, S3 buckets, SQS queues, and SNS topics with more to come. A self-service wizard will guide users through the process of requesting the IAM permissions they want, and it will generate the required cross-account resource policies automatically, all without requiring users to know the IAM permissions JSON syntax. Our long-term goal is to have your entire IAM workflow for all of your accounts in a single place. Everything I talk about today is something that you can do as well, because the tools we're going to talk about are open source. I'll provide links at the end. Let's start with the first features developed around credential brokering. In the early days, there were multiple ways to get IAM credentials at Netflix. One example. Users had a script that would SSH into an instance and steal credentials from the instance's metadata service. This was bad because it meant that multiple entities were using the same set of credentials, and it made attribution in our CloudTrail logs quite difficult. There was another tool that would take in a username, and it would use Duo as a single-factor authentication method before handing you credentials. It was lacking in robust security. Employees had a few other options at their disposal as well. At Netflix, ConsoleMe is now the only supported way for non-machines to get IAM credentials. We wanted ConsoleMe to provide all the convenience features that developers desired, with security and least privilege added in by default. Take AWS Console Access as an example. Want to integrate your favorite Spotlight or Hotkey app to log you into a specific role or redirect you to a specific resource? Want to create a Slack bot that provides you with a link to a resource that will both log you in to the console and redirect you to that specific resource's page? Not a problem. Let me show you 5 quick ways a user can log into the AWS console with ConsoleMe. The first way is the role selection page. Users would see all the roles they're authorized for on ConsoleMe's landing page. At the top, there's a configurable description where we tell the user where they can learn more about each of our accounts and what their intended purposes are, and an FAQ telling the user how to request access to roles. As a side note, we also have a Google Group access request feature that is built into ConsoleMe. So a user would request access to a group, and the owners of that group would be able to approve or reject it. The second method is through recent roles. We show a user their 5 most recent roles so that they can quickly log in much of the same way. All right. So a third way is through chatbot integration. We have a chatbot at Netflix called Sonar. If we give Sonar an IP address, Sonar will tell us if it's a Netflix asset, like an instance, VPC or NAT gateway. If so, it'll provide a link to the resource through ConsoleMe. The link will both log the user into the AWS console and redirect them to the specific resource. The one in this example is an EC2 instance. Okay. A fourth way is configuring your favorite Spotlight replacement or hotkey utility, like Alfred or Albert. In this example, we're using Alfred to quickly log into the console with a role of our choice. So I just configured a hotkey like R, type in a partial role ARN, and I'm good to go. In the last example, we're going to configure a custom search engine in our browser to convert the user's query into a URL that ConsoleMe understands. If I only have one role that I'm authorized for that matches this query, I'll be logged into that role. You can also pass in extra parameters to automatically log into a specific region or be sent to a specific service consoles page. ConsoleMe also allows users to request short-lived 1-hour credentials from ConsoleMe via the CLI. Our CLI utility is called Weep. Get it? Weep can authenticate your users to ConsoleMe through mutual TLS or by ConsoleMe's standalone challenge verification method. Weep supports 5 different ways of providing credentials as well. 1 is writing them to your AWS credentials file. 2 is exporting them as environment variables. 3 is running a metadata service locally to serve credentials via HTTP. 4 is configuring the AWS SDKs to invoke Weep on demand to source credentials. And my favorite, the last one, is emulating the ECS credential provider locally. Today, I'm going to show you both the metadata service mode and the ECS credential provider mode. Okay. So here I am running the AWS SDS getCaller identity command, basically a who am I command for AWS, and confirming that I do not have valid credentials. In the other tab, I run Weep and tell it to retrieve credentials for a role from ConsoleMe. and then to start a local metadata service on port 9090. I want to get credentials for a role called null role. I'm only authorized to get credentials for one role with the substring null r across all my accounts. So I can just type in that partial role name and ConsoleMe will figure out what I mean. After the metadata service is started, I rerun the whoamI in AWS command again and learn that I have valid credentials. Now I'm going to curl the metadata service to get an IP to get a token. Okay, this is going to be followed by a curl to grab the AWS credentials with that token. And this is the same flow that the AWS SDKs use behind the scenes. And there we go. Weep is also offered as a Docker image that can be used to serve credentials to other Docker containers or to your local host. I'd now like to show you Weep's ECS credential provider mode, which I think is the best option for most users. In this mode, each process or shell can use a different role. Credentials will refresh automatically for long-lived operations. No routing rules are needed, and it only requires a one-time configuration using an environment variable. For developers, it's really easy to configure an IDE with a run configuration tied to a specific IAM role, and to request access to multiple sets of roles in parallel. We will request the credentials from ConsoleMe, cache them in memory, serve them to your AWS SDKs, and refresh them when they're near expiration. So in this demo, we're starting Weep in ECS credential provider mode, and in the other tab, we demonstrate how we can request credentials for two different roles by just setting an environment variable that points to Weep. We first run the getCallerIdentity command with a role called ConsoleMe OSS1, and in the second one, we're using ConsoleMe OSS2. This flow works across all the AWS SDKs. This feature has changed the way that I developed personally, and I think it's a lot easier than other options. Let's move on to our second wave. Normally, if you want to provide permissions for a role to access an S3 bucket that's on a different account, you need to log into the account with the role, browse to the IAM console, find the role, and either use the built-in IAM policy editor to generate or to type in the JSON policy that the role needs. Then you'd have to log out of the current account and log into the account that has the S3 bucket. You'd have to create or modify the resource policy to grant the access and to establish two-way trust. But anyone with a career managing IAM permissions knows that there's more to it when we consider explicit deny policies, service control policies, permission boundaries, and session policies. Permissions are complex, hard to solve for, and prone to human error. We try to create an abstraction to make IAM permissions easier for both end users and administrators that I want to demonstrate to you today. Let's consider a new scenario and use ConsoleMe's self-service wizard. Let's imagine I'm the owner of a service called Happy, and I want to add some permissions to a role associated with my service. I reach out to your cloud administrators to get these permissions, and they redirect me to ConsoleMe's self-service wizard. And I'm going to show you that flow now. This is the page I see in ConsoleMe. I start typing in the name of my application to identify the specific role needing permissions. But once I select the right role, context about that role is going to appear. Who owns this role? What applications are associated with this role? Were there any recent CloudTrail or S3 errors on the role? What tags are on the role? The information shown here is customizable. You could link to the CI/CD pipeline associated with your application if you wanted to. On the second page of the wizard, we try to get the user's intentions. All of the dropdowns and dialog boxes here are based on a YAML configuration, so it's really easy to update the choices with your most common permission requests. ConsoleMe has type-ahead support for most fields to make resource selection as easy as possible. So here we are in self-service, and we want to get access to an S3 bucket, a cross-account SQS queue, and the recognition service. S3 and SQS are fairly common, and they have native support in ConsoleMe. recognition is not as commonly used. You'll notice there's another dropdown called Other. This option provides a CRUD mapping of operations for all other AWS services that ConsoleMe doesn't natively support. The mapping is generated by a library written by Salesforce called Policy Sentry. So once I've made my permission selections, I can go down and I can click the next button. So on this page, I'm going to see a summary of the permissions I requested. If I didn't need anything custom here, I could just type in my justification and submit my request. Power users or users with more requirements can actually view the JSON policy we generated and modify it before submitting the request. And all of ConsoleMe's policy editors support type ahead for actions and your AWS resources. You'll also notice that each policy statement has a statement ID. In that SID, we identify the user and the time of the request. So if someone is looking at a role's policy in a couple years' time, when all of your CloudTrail and AWS config historical records have gone away, this provides us with an easy way to identify who made a change and when. After we're done here, we're going to go to the bottom, we're going to type in a justification and submit our policy request. When a policy request is submitted, the reviewers of the policy get an email and at Netflix a Slack message notifying them about the request. There's also another step here where we determine if we should automatically approve and apply the policy or not. AWS Zelkova is one of the elements in AWS's Provable Security Initiative. It's a policy analysis engine that can automatically detect entire classes of resource misconfigurations using mathematical proofs. One of the things that we use it for is to compare policies in ConsoleMe's self-service framework. As soon as the user clicks the Submit button in the IAM wizard, ConsoleMe uses Zelkova under the hood to analyze a user's policy request against a set of probes that we've defined. And it uses the outcome from Zelkova to determine if the user's request should be automatically approved and applied. At Netflix today, around 20 to 30% of our incoming IAM policy requests are automatically approved by this process. Our Zelkova probes are nothing more than IAM statements that look like this on the right. Zelkova will tell us if the user's policy request is equivalent, less permissive, more permissive, or incomparable to the probe. If equivalent or less permissive, then the request will automatically be approved and the permissions applied. Let's give an example. Let's say that you have a library that makes the assumption that the role you're using has access to a specific SQS queue. That it wouldn't by default. By the way, assumptions like this are bad, so please don't do this. But anyway, you could write a probe that will automatically approve and policy requests that just want access to this particular queue. You can also restrict the probe so it only applies if the requester is a member of a certain team. For example, we have a team at Netflix that manages S3 buckets, and we've created a probe that gives them the ability to request a wide variety of S3 permissions without needing to go through policy review. We have another team that manages cloud network access. We have a probe that auto-approves ENI permissions only when they request it on a role. All of this is done without giving extra IAM permissions to these teams. So back to our IAM policy request. We've submitted the policy, but it wasn't auto-approved by our Zelkova workflow. This is the policy request review page. The top of the page shows context about the user and can include a link to their profile if ConsoleMe is aware of it. You'll notice context about the role, a link to the role's policy editor page in ConsoleMe, and details that you might care about regarding the request. For example, when the request was created or updated, and whether the request includes any cross-account resources. Approving a change in the request immediately applies the policy to the resource. We're operating as an administrator here, so we get access to approve, update, or cancel each change in a request. Normally, end users can update and cancel requests, but they can't approve them. This editor has the same type ahead features that the previous one had, so we can update the user's request if they got it wrong, and so can the user. And we're notified about any changes or anything like that before submission. The second policy was not explicitly requested by the user. ConsoleMe saw an SQS queue in the request and determined that the queue was in one of our other accounts. Because of this, ConsoleMe pulled the queue's existing policy and generated a new policy statement to allow the cross-account request. The policy review framework here gives IAM administrators the granularity to apply, reject, or update specific changes in the request, to interact with the requester via comments, or to reject the entire request. Now, what if you're an administrator or a power user and you didn't want to go through a wizard because you knew exactly what permissions you wanted to apply? Today, ConsoleMe has a native policy editor interfaces for popular resource types, allowing administrators to submit or modify policies directly. And users also have the option to submit policy requests or changes here as well. The policy editor in this demo is for an IAM role. On the top, we provide a link to S3 and CloudTrail logs, and a link to the role's AWS config timeline, which shows changes to the role for the past 30 days. Your IAM administrators can create or update policies across all your accounts, roles, S3 buckets, SNS topics, and SQS queues without having to log in or out of multiple AWS accounts. Your end users can submit requests to create or update policies without needing additional permissions in the AWS console, and it works like the wizard. If we want to create a new inline policy, we just click the Create New Inline Policy button, and it shows a list of policy templates that you can configure. This allows your users and admins to easily add or request common permissions. Once we select a template to use, that template will be placed in the editor, and the user will just replace any values that they needed to replace. This was version 1 of self-service IAM before we created the IAM wizard. You can update the assume role policy here in much the same way as the inline policy. This role has a few managed policies, which admins can manage and end users can request. As a side note at Netflix, we strongly prefer inline policies for adding role permissions. This is because we want permissions that are specific to each role. This makes it easier for us to remove unused permissions down the road, which we do with a service called RepoKit, which you can find on Netflix's GitHub page. Admins can manage tags, and users can request tagging changes here as well. And then under the Issues tab, we aggregate and expose the top 5 CloudTrail and S3 errors that have occurred for the role within the last 24 hours. An eventual goal of ours is to provide a one-click fix-it button that will submit a policy request to fix the permission issues for the user as automatically as possible. Let's talk about the third and final wave. Managing resources across accounts is complex and time-consuming. We try to develop features that will reduce the time it takes to complete common tasks, such as changing the policy of a resource. We basically want to free up the time of our engineers so that we could gain a constant source of dividends that can be spent on more high-value work. We mentioned previously that ConsoleMe centralizes a lot of your organization's policies. We do this by syncing your resources from AWS config across all your accounts. We created a single data table view exposing this information to your users. If we don't have a native interface for the resource in ConsoleMe, we provide a link that will both log the user into the correct account that the resource resides in and redirect them to the specific resources page, or as close as we can get. Here's a quick demo of that. On the top of the page are the filters, where you can filter by account, resource, or resource type. You'll also notice that we have a column for errors, which shows the number of CloudTrail errors that we've seen for the resource in the last 24 hours. Once I click on the resource, if it is a resource we have a native policy editor for, we'll take you to that resource editor in ConsoleMe. Otherwise, ConsoleMe will attempt to log you into the right account and redirect you to the resource. If you're not authorized to use any roles on the account, you'll get an access denied error. If you're authorized for multiple roles on the account, you'll be prompted on which role you want to use as soon as you click the resource link. This feature drastically reduces the amount of time it takes to find a resource in the AWS console. So one of the last things I want to talk about briefly is how exactly does ConsoleMe make decisions? ConsoleMe uses role and resource tags to determine who can do what with a given resource. These tags indicate who the owner of a particular resource is, which applications are associated with the resource, and which extra users or groups can retrieve credentials for a given role. This is one of our efforts towards attribute-based access control. The source of truth is attached to the role or resource itself. This makes access decisions easy to reason about and simple to fix. You just need to update a tag. One thing to note about this model is that it's important to choose your tag names carefully because they're being used to make authorization decisions. This means that only certain services should be allowed to change these particular tags. At Netflix, we have a specific tag prefix we use, and we make use of a service control policy to prevent any unauthorized users or applications from modifying these tags across all the accounts in our organization. In the future, we plan on using these tags to support automatically approving and decentralizing permission requests. For example, if one of your developers wants permissions for their application to access an S3 bucket that their team also owns, the resource isn't sensitive, and the requested policy isn't too excessive, why does security need to be in the loop? If this developer's team owns the role and the resource, there's little chance that security will add any additional value by reviewing the request. So, did ConsoleMe make a dent in operations at Netflix? Well, it's hard to say. We don't have the millions of samples needed to reach an honest, objective conclusion. Our team and other teams work on several initiatives in parallel that can strongly impact operations for better or worse. But when I'm cuddling my ConsoleMe pillow right before I fall asleep, I tell myself that yes, we have made a positive impact. On the left is the same graph we showed earlier. Netflix headcount grew by 70% in this time period, and the number of requests our on-call fielded increased at a similar rate. The graph on the right shows the number of requests our on-call received in red after we started releasing self-service features. The number of requests shown in red trended downwards despite an increase in headcount of around 30%. However, the blue bar shows the average number of back and forth messages between our on-call and the requester before their issue was resolved. The bigger the blue bar, the more complex the request is, and complexity appears to be trending upward. This might be because the easier use cases are solved by ConsoleMe and other tools. So although it's hard to reach an objective conclusion, we've heard great things from our users about the benefits of ConsoleMe and how it saves them time. Our goal is to keep improving ConsoleMe and automate as much of the space as possible so we can empower engineers to spend their valuable time solving cutting-edge problems instead of wrestling with permissions. I mentioned earlier that you could do the things we discussed during this talk, and that's because ConsoleMe and Weep are now open source. There are several other features in ConsoleMe that we didn't have a chance to talk about today. If any of this piqued your interest, please check out our GitHub pages, join our Discord channel, and reach out for more information or help. We're very interested in your ideas and feedback, so bring it on. And that's all. Thank you for attending my talk. I want to give a special thanks to Heewon Kim, Patrick Sanders, Srinath Kuravati, Jay Dulia, Kinnaird McQuaid, the Cloud Infrastructure Security Team and InfoSec teams at Netflix, and our AWS partners. So when all our problems are solved and automated away in the future, I plan to rest and I want to look cool by riding a jet ski like this without a worry in the world. Don't forget to fill out your session survey, and thank you all again.